Welcome everyone to this webinar. I must appreciate that BAS has been organizing these webinars every Sunday with regularity, and they're quite interesting. So thank you for inviting me today. 2 Sundays back, half a lunation back, I was at Sirsa along with my family and a few friends. Some of them have joined in this webinar. Adi is there, Manish Sharma is there, and I think a few others will be joining in a short while. Is everybody able to see my presentation?
Yes, sir.
Now is the presentation visible?
Yes, it is visible.
Thank you. So half a lunation back, 2 Sundays back, we were at Sirsa and we were under the shadow of the moon. Um, the preparation for this eclipse, which was passing through India, for me started in 2011. There was a solar eclipse conference organized at Delhi, and there were many international personalities who had joined, who had come into India. Uh, there was Mr. Fred Espinag, Xavier Jubier, and many other great personalities connected with eclipses. And in 2011, in that conference which was held at Delhi, I had given a presentation about the eclipse, this solstice eclipse of 2020. So I had started my preparation. To make the presentation, I had to go through everything. So this is one of the video that I prepared from using Google Earth of the path starting in Rajasthan and going over Haryana, Punjab, and the Himalayas. So my preparation started. So in that conference, uh, when I presented, I've said this is a simple presentation with an intention to build up some euphoria over the solar eclipse 9 years in future on a few hours after the summer solstice of 21st June 2020. To be exact, 3,110 days from today. Is it too far in future to plan? I don't think so. So that was my statement when I had started my presentation. And over the years, I kept on building, kept on preparing what to do and what to like. So these are some of the maps that I prepared in the interim as a preparation for this eclipse. And the eclipse was passing through 5 places. And the first and foremost was, where would I go to watch this eclipse? It was passing through such interesting regions. And the first place that I considered to see this, go and see this eclipse, was Kailash Mansarovar. It's a, I think everybody's ardent desire to go and visit the Kailash Mansarovar. Uh, I couldn't go there, but these are some photographs from my friend and colleague in Tuan, Jeff Dye. He was able to go to Kailash Mansarovar. On the left is a photograph of the Milky Way, and under it you can see the Kailash Parvat, and there's a big bolide which he captured in his photograph. And also on 21st June, he captured some of these photographs. So he was able to go, I was not. I also considered going to Hardeol. It's a peak which is the highest peak in the path of this particular eclipse. This is an image which would be used in planning. So B1 plus B2 is a base camp. Well, the thought occurred to me, but I dropped it immediately because I'm not capable of joining any expedition which is technical and really. Actually, there was nobody on top of the peak. If somebody was there, it would have been a record. The other place that I wanted to go was this place is called Gorsan Bugyal, and it's very close to Oli in Uttarakhand. And you can see the Nanda Devi peak from this Gorsan Bugyal. So if you see below, this is the Bugyal, and this is the Nanda Devi peak, and it's a fantastic place. You have to trek to this place, and the distance of this trek from Oli is about 3 kilometers. So it would have taken about 3-4 hours, maybe 2-3 hours to climb up to Gorsan Bugyal. Recently, in a couple of years back, Uttarakhand government has passed a rule that you cannot stay at these places at night. So that was one difficulty. The other difficulty was that you would have to hire porters and take a lot of permissions to go to this place. But if I had gone there, it would have been fantastic. Probably this site would be above the clouds on 21st June. The final destination that I very strongly prepared for was Suratgarh. This is an image from the sand dunes of Suratgarh. They're not very big, and they're called Tibba over there. So I had planned to be very close to this particular Tibba in Suratgarh. Well, my final destination was Sirsa, and I would like to explain a bit why finally Sirsa was selected. And in this map, you can see that the path of the eclipse is crossing through Punjab and Haryana. And this over here on the left is the Sirsa district in Haryana. And this is very close to Rajasthan. So this part is the state of Rajasthan, and Sirsa is over here. And this is very close to Rajasthan. And in fact, Sirsa, the district of Sirsa has some sand dunes also. So the weather between Sirsa and Suratgarh, if you go westwards along this path, Suratgarh is somewhere just outside this image. And I studied the weather of Sirsa and Suratgarh for the last 20 years for the month of June every day at noon. So I found that there are a lot of storms, Andhi, in the pre-monsoon season over here. It gets very hot, about 45 to 50 degrees. And when it gets hot, all the air rushes in, and there's a storm which erupts suddenly in these parts. And what I found was the Sirsa and Suratgarh, if there was a storm at one place, there was certainly a storm at the other place. So the weather would be same, exactly same at Sirsa, with a 10% more cloudiness at Sirsa. So this was a good compromise to stay within the state, because I live in Haryana, somewhere over here at the bottom, and traveling to Sirsa would be no problem, because there would be no restrictions, no permissions to ask for, and I would be easy. And driving to Sirsa would also be 100 kilometers less than Suratgarh. So this is a place that I selected, and these were the reasons. Incidentally, we were at a place called Ganga Greens, and it's a large marriage garden actually, and they were owned by people called Mehtas, and they were really gracious, and they provided us all facilities for the eclipse. Fantastic place. In this slide, I would like to discuss a little bit. On the left, you can see, I would like to discuss a little bit of eclipse geometry. On the left, you can see the diagram of the penumbral lunar eclipse of 5th June. Half a lunation before the eclipse. And on the right, you have the penumbral lunar eclipse, which is actually happening right now in America, in the American continent. So over here you have the umbra of the earth, and this is the northern direction, and you can see the points of the penumbral contact. This is contact point P1, this is the maximum, and this is P4. So at P1 the moon is entering the penumbra. At this point it is the maximum ingress, and P4. So you can see that this line making an angle with the ecliptic is actually moving towards the ecliptic. And over here in the penumbral lunar eclipse that is happening right now, or of course not visible in India, you can see that this is P1, and when the moon enters the penumbra, this is the maximum eclipse, and P4. So you can see that this line of movement of moon is inclined to the ecliptic. That means it is moving away from the ecliptic. So you can very well deduce that this is half a lunation before and this is half a lunation after. And where would moon be with respect to the ecliptic? So in between these two dates, the moon would be exactly on the ecliptic, and it's becomes a little easy to understand about the eclipse that happened on the solstice day. I would like to show a movie, a 4-minute movie, which was a result from Sirsa. It contains many elements, Bailey's beads, then unfiltered photography of chromosphere, and I will point it out, corona also. Then eclipses formed due to pinholes, and I would like to tell you that the music for this movie was made by my son Arjun. So let's enjoy this 4-minute movie. Vishwa, will you be able to tell me whether you are able to hear the music?
Yeah, Ajay.
Thank you.
Yeah, we can hear.
Thank you. Well, it was really hot over there. Uh, the temperature was soaring into 45, and we were afraid. There was some prediction that there's going to be a storm along with some stormy rain, but that prediction was for after the eclipse on 21st. But as it happened, that storm came one day earlier to our great relief. And when the storm came, the wind was blowing really furiously, and we were standing outside holding to our telescopes and getting drenched in that storm. But still, it was fun. So we were relieved quite a lot because the storm had come, and next day it would be slightly cooler, and we would be able to enjoy it. So that's what happened. But there were some clouds which came just before the 10 minutes before the annularity, and that made us really afraid that we were going to miss annularity. But as it happened, that the entire eclipse was beautifully clear, and we were able to do some unfiltered eclipse photography. Now, this deep annular of 21st June was so thin that unfiltered eclipse photography was possible. So let me show you some results. This particular image sequence has been clicked with a 400 lens, and there was a bracket of the camera used was Canon 5D Mark III, which is quite a quick camera, and it was able to shoot one image per second. And I had put a bracket of 8 exposures, and this is the least of the exposures which captured the chromosphere as well as the corona. So these 10 images have been shot starting just before second contact and ending just after third contact. So you can see that the moon has moved from top to bottom along with the sequence. And this photograph at the bottom, which contains prominence at the second contact point, here is a prominence, was shot with a 14-inch telescope. There was a slower camera attached to this particular mount. The camera was Canon 1000D, and it was able to shoot one image in a matter of 2.5 seconds. If I had programmed anything faster, there would have been the images would have been skipped. Now the 14-inch telescope was pointed at the southern edge, southern PA, 180 PA of the sun, because I wanted to capture more and more beads over there. But this part of the sun, which is near the second contact, was inadvertently, it was not aimed, but I got lucky and I got this prominence. Uh, so this is just before second contact, and the second contact is approaching. Now you can see the chromosphere over here, and I think the second contact, the point of second contact is over here. So just before second contact, the camera captured prominence at the PA of the second contact. So here's the setup from which the filters were removed. So this is a 14-inch telescope. Excuse me, please. So this is a 14-inch telescope. This is the green color filter is there in front, which was removed during annularity, and below this there is a stop. So this is a 14-inch telescope with a focal length of 3910 mm, but a stop was installed in front of the telescope, and the telescope was operating only at 3.5 inch. So the telescope is 14 inch, but it was operating at 3.5 inch. And the focal length is 3910 mm, but over here there is a focal reducer. So that made the focal length of this setup to 2742 mm. And the camera is attached over here. This camera is a slower one, 1000D. And on top, piggybacked, is the Canon 5D Mark III with a 400 mm lens. From both of these two, you can see a ladder which was placed close by so that we could climb up and the filters removed. So this was a setup that took the unfiltered shots during the annularity. There were a lot of people with me at Ganga Greens at Sirsa. One of them was Mr. Manish Sharma, and I'm going to show some of his pictures. Here is a picture actually. He is a very shy person. He never quietly he was photographing, and you can see that his camera has a shade, and he's carrying an umbrella. So he was well equipped. You can also see a cloth which he was using to cover the camera and his face. So he was well prepared. And this is what he shot: unfiltered shot, uh, capturing the same prominence over here, corona and chromosphere, and lots of Bailey's beads. So his photographs are traveling the world, appreciated all over the world in eclipse circles. So congratulations, Manish. He is here today with us in this webinar. Well, at this moment, I would like to see if there are any questions and answer them. If anybody wants to ask a question, he can unmute himself and speak. There is a question from Sahir Barik. What is umbra and penumbra? Whenever you have a shadow, the dark part of the shadow is called the umbra, and the lighter corner part is called the penumbra. Vishwanath has already explained this question a bit. In eclipses, lunar eclipses, you have the shadow of this Earth falling towards the moon, and the central dark part is called the umbra, and the penumbra is the periphery part, which is not so dark. Kirti has asked, what kind of processing do you do to these images? Well, I mostly use Adobe Camera Raw. So this series of images on top have been processed purely in Adobe Camera Raw. So the bright portion, the sun photosphere that was visible, was reduced by using the sliders, the lightning, the sliders in the Photoshop, and the darks and the shadows were brought up, and the chromosphere color was enhanced. The chromosphere color was also enhanced selectively. So you can see that this color is sort of magenta and pink, and this color was enhanced selectively. So all these controls are there in Adobe Camera Raw, and there was no other processing software used for making these photos. Any other question at the moment? Okay, I will continue with my presentation. So before the eclipse, we had made a plan. What did we want to image? What was the list of images that? So this was our photo plan. First and foremost was to provide a live feed to timeanddate.com, and also provide a YouTube live feed. So these were two different feeds that we were planning to provide. The time and date was the primary one, and secondary one was YouTube live, and both were to be broadcast using different equipment and different internet connection. Then locally at the resort, we also had a small finder scope along with a camera to show the live view on screen. Like we could just hook it onto the TV. So these three live programming were there. Then the next came, we wanted to shoot Bailey's beads without filter, Bailey's beads, chromosphere, and corona without the filter. And we wanted to shoot Bailey's beads up close, like with a long focal length, but with filter. So these were our main photo plan. Then of course we wanted to shoot the ambient light dimming and compare it to the other annular eclipses. Then pinhole projections. We also wanted to make a time lapse under the tree, but at Ganga Greens there were no particular trees. Uh, very small plants were there, so that project never took off. That time lapse under the tree we could never make, but we did compensate. We did get some good pinhole projections from the. I'm going to show it to you. Then of course I wanted to complete half a tutelema. Tutelema is an NLMA with an eclipse, and there was a roving camera which Neelam was managing, and it was shooting the expressions of the eclipse chasers and then sharpening shadows. I'm going to show some results from that roving camera also. This eclipse was basically a Bailey's bead special. Since the diameter of the moon and the sun was so close to each other, lots of Bailey's beads were seen and photographed it was so easy to photograph Bailey's beads in this particular eclipse. This is a movie that I want to show you, which was captured using a 12-inch telescope. The focal length of the 12-inch telescope was 3000 mm, and it was connected to a full-frame camera. So the focal length of 3000 mm cannot capture the entire sun, and the telescope was on an alt-azimuth mount. So it gets really confusing when you want to point this alt-azimuth telescope to the sun and deciding where exactly is your camera looking, and especially when the eclipse is happening very close to zenith. So although we have captured lots of Bailey's beads, let me start this movie and I'll explain along with. So behind you can see that 12-inch camera, 12-inch telescope. So here the Bailey's bead have started, and ideally this camera should have been pointed more on this side. But nevertheless, you will see that we captured so many Bailey's beads anyway. If you also look carefully, the Bailey's beads are always there at some point or the other. What does this mean? That means there was no annularity at our location. We were about 3.6 kilometers north of the center line, and we never experienced annularity. So I'm going to play this movie again and show you. So here you see that this is a bead. The sun's annular, the ring of fire is never complete. So the Bailey beads are moving over here now. And the beads are starting to appear on the other side. So at our location, there was no annularity, but it was predicted. It was predicted that we would have about 12 seconds of annularity, but that never happened. So I have sent this video to David Dunham, who's with the International Occultation Timing Association. He's going to analyze this video, and probably we will have a better understanding of the lunar limb that was presented. So according to the calculation, we should have had annularity for some few seconds, but we did not. So there was a change in the moon profile. So let's see if something comes out of our observation of Bailey's beads. This was the telescope, 12-inch telescope. It was always filtered. Filter was not removed, and there was a camera, full-frame camera attached behind. And a movie was started. This was not photographs. Movie was started about 10 minutes before C2, second contact, and it kept on clicking till after the third contact. Other people who were with me, other observers, Adi Vishal, they also captured the Bailey's beads very nicely. Adi was using a 8-inch telescope. I think he was using a focal reducer along with, so that makes the focal length of his setup to be about 1250 mm. So this is what he captured, uh, Bailey's beads at second contact. I want to discuss how much rehearsal does it take to get everything, all the projects going in an eclipse. So here's a movie which my son Nakul captured. This is during the first day of rehearsal. So you can see all the equipments are being tested. Everything, all the cables, everything is being aligned. So this is on 19th June. So we did 2 afternoons of complete rehearsal with everything on. And then we discovered many problems and we tried to sort them out. Even before reaching the site at Sirsa, we were doing rehearsals at Gurgaon, where I stay, and we discovered that the cameras were getting hot, the telescopes were getting so hot, and the counterweight, especially, would become so hot that it would not be possible to touch it. If you want to lift the counterweight, the hot metal would, singe your fingers. So I was thinking, what was the problem and how to solve this problem. And one of the endeavors was to broadcast on YouTube using a cell phone, and that cell phone was getting really hot, and it would shut off. It would go off. So what was the solution? I wanted to blow cold air on it and take an air conditioner along, but all that was not possible. And then suddenly, about 3 days before, it occurred to me that we could use outdoor desert coolers, and that's what we have used over here. Over here you can see a outdoor cooler with water running behind. So we have employed 3 coolers, and we were able to hire them at Sirsa, and you can see that they are blowing cold air on the instruments, and even under the gazebo there is a cooler over here. So this was very important, and everything was cool. I can tell you it was so hot over there, but because of these coolers, we were able to manage for these 3 afternoons. This was a setup which was providing local live feed on the television, and this camera was capturing the ambient light dimming. Well, Mr. Amit Bhattacharya was with me on location at Sirsa. He is actually a senior journalist with Times of India, New Delhi edition. And next day, in the next day's papers, 22nd June, his photograph from Sirsa was published. But of course, so I wonder if Amit has joined us today over here. So this is what he captured from his telescope. He was using a Schmidt Cassegrain. I think he was using a 6-inch telescope with a focal length of 1500 mm. And this is the shot of Bailey's bead that he captured at Sirsa. Another eclipse chaser who was with us, his name is Alok Tayal. He lives in Noida. And this is his rendition of the eclipse photography. So he has joined the stages of the eclipse that he captured. along with the map and path of the eclipse over India. And another image that he has produced is first contact, although this is not first contact, this is a little after first contact. Then at 25% obscuration, 50, 75, then a photograph at second contact maximum, third contact, and so on and so forth. So this is fourth contact, just before fourth contact. And as I was mentioning, we had a roving camera, and this is really interesting. Portrait of an eclipse chaser. Adi is an artist who made the sketch of Neelam on a cardboard paper, and pinholes were drilled, not drilled actually, punched into that cardboard paper. And the sketch of Neelam was really realistic. And later, the holes that were punched really brought out the sketch. So let me show you this small video. And this is the most interesting thing that we captured during this eclipse. So here is a cardboard with the holes punched in the shape of a sketch of Neelam made by Adi. And what I want to show over here is when you move the cardboard away from the screen, the crescents get bigger, and when you move it closer to the screen below, the crescent gets smaller. Just watch. Now the screen is moving closer to the, sorry, the pinholes are moving closer to the screen. See how it changes. This is really interesting. I'm going to play this video again, and because this is the most interesting takeaway from this eclipse.
Bring it little down now and then go up.
I got really scared before the ये जब हो रहा है तो साइड लाइट में आप एक लाख की चीज़ को पैकेज में दो जैसे मैं पहले ऑर्डर किया था
This is so beautiful.
Okay, would you please give me one moment, because I have forgotten to include one image in my presentation, and I'm going to go on Facebook, and I'm going to share it in a moment. Please give me some time. Okay, I'm already on Facebook, and I'm looking for, okay, I found the image, and now I'm going to share that particular tab. I'm going to stop presenting. Okay, this is a photograph which I forgot to include in my presentation, and this is another good takeaway from this eclipse is the photograph of corona. And this photograph I have named it as atmospheric, because you can see the atmosphere of the sun, which is the corona, and you can see the atmosphere of the earth, which is the which are the clouds in front. And this has been taken with a 400 mm lens from which the filter was removed. So this is one of the most satisfying image that we captured in this annular eclipse. Okay, I'm going to check on the questions for the moment, answer them, and then move on with my presentation. Sahir Barik has asked, what's Bailey's beads? Well, the eclipse community takes a lot of offense if you spell Bailey's beads wrongly. And the spelling of Bailey's beads is Baily apostrophe S and beads. And Bailey was a person who first proposed and postulated and observed Bailey's beads. Bailey's beads are caused because the sun is shining through the valleys on the moon. So when the moon comes in front of the sun and the edge of the moon is going to be aligned with the edge of the sun. So at the second contact and at the third contact, the sun is shining through those valleys and sun gets separated, like the crescent sun gets separated into dots, and those are called Bailey's beads. Sahir has also asked, have you watched Total Solar Eclipse? Yes, many times, starting from 1995. Sriram has asked, when predictions of the duration of annularity are made, is the lunar limb profile always taken into account, or it is assumed to be smooth for simplicity? The answer to this question is that when predictions are made, that it is assumed that the moon is smooth. So according to that, at our location, the annularity would have been for 38 seconds. But when you take the lunar limb profile into account, the annularity was much reduced. And according to calculation, it was about 12 or so many seconds. But what we observed, that there was no annularity at all at our location, which was 3.6 kilometers north of the center line. If we were at the center line, there would have been annularity of a few seconds, but since we were not, we'd never had annularity. Kirti Kiran has asked, do the coolers affect seeing? Oh yes, definitely. They affect seeing, and they were causing vibrations because they were really industrial coolers which were blowing the wind at a very fast speed, even at the lowest fan setting. So we had to place them really far away. But the heat was so much that they were providing some relief. So yes, they would affect seeing, and since the sun was right on top at zenith, it was another cause for seeing deteriorating. So of course, but then we could manage so easily just because of the coolers. And even on the second day of the rehearsal, my laptop shut down. The reason was that the adapter was not able to provide electricity. It was getting hot. So just before I started work on the day of the eclipse, I kept the adapter of my laptop in front of the cooler, which was there inside the gazebo, and that's how it kept cool and the laptop kept working. So did the coolers affect seeing? Most definitely, but because of them, we were able to see the entire eclipse without any hitch. Kirti Kiran has asked, in the corona image, which part is the corona? Is it the thin glow that you see just around the dark limb? Yes, Kirti. So if I go back to the image of the corona, uh, if you can unmute yourself and let me know if you can see my cursor. Can you see the mouse pointer?
Hi, Ajay. Yes, we can see the cursor.
Okay, so this is the uneclipsed part of the sun, and it's not yet second contact. Second contact would be when the moon has moved a little towards this side and the sun appears on this side, but this is just before second contact. On the edges over here, you can see some chromosphere, and this is the corona, the innermost corona, just a little whiff, but this is most definitely the corona and not a atmospheric effect of the earth. So this is corona. Why I say so confidently? Because it's there in every image that was clicked before the third contact. Does that answer your question, Kirti?
Hi, Ajay. Yes, yes. Yeah, I thought so, but there was glare also in the image, so I was not very sure whether whether we were seeing only the innermost corona or also something which is extended. So that's why I asked the question. Thanks.
Yes, that's right. Even I was not very sure, but then when all the Eclipse processing was over and I was comfortable, and then I sat and watched these series of images. Uh, so every image, the glare, the flare was changing, but this was always constant. So that's how I deduced. In fact, when I produced that collage of 10 eclipse photographs in a line, those also have the corona inside visible, but I was not so sure. So I released this inner corona image about 5 days after the eclipse.
Okay, cool. Thank you.
Okay, Sriram has asked if I were to image an annular eclipse with a similar geometry, when I analyze the image after taking, how do I ascertain that I have indeed got the corona in the image and it is not an optical artifact? Well, I was able to deduce because it was there in many images before third contact. So that was my deduction process, and that is a deduction process of any astrophotographical image. Like if you're shooting a deep sky photograph and you get a line, what would you assume it to be? So you check the next image and you check the next image. So if it is an error, it will be only in one image. If it is a meteor, it will be there only in one image. If it is a satellite, it will be there in two, three images. And if it vanishes, that means it is some artifact. So this is a regular process. So that's what I use. That means many of my photographs have corona and they are looking the same and different from flare and the glare. So that's what was my deduction that these images indeed do contain corona. How much would a beginner's camera setup with telescopes and every other accessory would cost for astrophotography? Uh, well, this is off topic, but I would just answer it with one word. If you want a solid, no nonsense, you can get a EQ6 at the minimum, and that would cost you around 1.2 lakhs, and then a camera and a telescope. But well, let's get back to my presentation on eclipses. I'm going to stop presenting and shift. Okay, back to my presentation. So here is Adi and his wife Aruna. You can also see Shishu, and I would like to explain how that pinhole image came about. So this is another pinhole image that Adi made. This is a sketch. First of all, a sketch was made by Adi, who is an artist, and then pinholes are made a tedious out of the mind of Neelam just one night before the eclipse, and all Neelam, Adi, Aruna, and Shishu were working the night before the eclipse, and they were making these sketches and punching pinholes in them to produce this. So this is Aruna over here, Adi's wife, and this is the eclipse Aruna. So this is the most interesting thing that we captured during this. Such a simple thing and highly artistic. Here is a time lapse of the pinhole eclipses. You can see the map of India and a very thin line of the path of the this eclipse. And as you can see that the screen is being captured by a camera and is following the sun. Some clouds appearing, and the eclipse would just turn in an instant or is already turned actually. So let me show you again over here. So the eclipse is on the left side and suddenly it is turned. Just a second, I'll play this video again. So here you have full sun and then it's turning to crescent and suddenly it will turn now. There you are. So I had planned this in the annular eclipse of December 2019, but I was not very successful. But here I was able to make this time-lapse movie. Let me show you the setup that was used. So here this black plywood piece contains pinholes with the shape of India map and the path of the eclipse through the states. And here is a screen which is actually made up of glass and a translucent plastic sheet has been stuck on it. And you can see the adapter for the cell phone, which cell phone was put over here, and the entire setup is on a polari. That means the entire setup was pointing towards the sun continuously. That's how the frame remained pointed towards the sun, because it was on a polari tracker. And of course there was a sturdy tripod, and you can see those bungee cords which are holding the entire assembly rigidly to the ground. There was a big stone kept over there so that the setup does not move. Here is a very simple and interesting photograph by Kriti Tayal, who was also there with us at Sirsa. She carried a kitchen strainer, puri talne wala, and it has holes. It's a very simple but very satisfying picture made by Kriti. My pet project for this eclipse, Solstice Eclipse, was the Tutelema. I had started photographing the sun at 12:45 every day at Gurgaon, above my home on the terrace, exactly at the same time. So it's making a sort of S curve. Now, this is not very successful because you can hardly see the eclipse on right on top. The image is over there, but the image I should have taken the filter off. I should have taken the filter off, and I should have the eclipse shining over here. I'm going to still complete this tutelema and make the figure of 8 complete in the entire year. I've already started photographing again at the same time. But let me explain this photograph to you. The photographs, everyday photographs were taken at Gurgaon, and the difference of latitude between Gurgaon and Sirsa, Gurgaon is a little southern side and Sirsa is a little north side. 1.3 degree is the difference. So at Gurgaon, I placed my camera exactly at 45 degrees above the horizon. 45 degrees above the horizon. So when I was at Sirsa, I had pointed my camera 1.3 degrees little lower side because I had moved to Sirsa, which is towards the north. And the eclipse was going to happen at Sirsa at 11:56. But daily, my photography was at Gurgaon was done at 11:45. Why earlier? Because Sirsa is westwards as compared to Gurgaon, and the time difference is because of the longitude difference. So pointing the camera in the right direction was important. And this image, this background image was completely taken on a separate day. This is the Gurudwara at Sirsa. The name of the Gurudwara is Chilla Sahib, and it has got a big, beautiful reservoir over there. So all these elements have gone into making this picture of Tutulema. I'm going to complete it and present the results in February next year. Let me check on the questions. Kirti Kiran has commented that Aruna is the charioteer of the sun. Awesome job, Adi. Yes, thank you, Adi. Those sketches were really good. And I also thank Shishu, who's not here, for making those pinholes punching those pinholes so nicely. Kirti Kiran has asked, there were some water bottles tied to the counterweight. Doesn't the weight shift as the mount moves and change the balance? Kirti, the water bottles were full and tied very nicely, so there was no water shifting. 2 kilos had to be added onto the counterweight because I had piggybacked a 400 lens on top of the 14-inch. Vishwanath has asked, what is the reason for large gaps in the tutelema? Well, the reason for large gaps is one, clouds. Second, I am not there at home at 12:45. And third, some of the days I just plain forgot. So subsequently, I set a daily alarm, and every day it beeps me at 12:30. Sorry, 11:30. Sriram has said, while observing the partial eclipse from Bangalore, where the maximum obscuration was around 36%, I felt as though the quality of the light had changed, as though it had gotten softer compared to a normal day. Although most people would say that it's not possible to see any noticeable difference in the ambient brightness with such a shallow eclipse, from your experience, is it at least theoretically possible for a keen observer to notice a change in light? The answer is very much so. There was a eerie light. Now everybody uses a eerie light. This time I tried to analyze why everybody says eerie light. Because the sun is there in the sky, high up in the sky, and the light is reducing. So normally in our daily routine, when does the light reduce? Either it is there at sunrise time or most probably at sunset time. So when the sun is going down in the western horizon, this light reduces. But what happens? It turns reddish because of these refraction from the Earth's atmosphere. The sunsets are usually orange and red. But what happens when the sun is there right on top above you and it is reducing? It is distinctly blue. It is distinctly, you could call it electric. That's why everybody around the world says that the eerie light, it was distinctly bluish in color. I observed it. So what you're saying is absolutely right. And you have said that Bangalore, it was 36%. And I noticed the same thing when the eclipse was around 40 to 50% at my location of Sirsa. It was really, basically it is because I feel that it's because the light is more bluish than the normal reduction is light that we see at sunsets.
Thank you so much, Ajay, for answering that question. That's a question which has been nagging me for quite a while now, and most of the searches which I didn't really give me any conclusive answers. In fact, I'd actually searched for a brightness curve during a solar eclipse, and I got a paper which was made during the total solar eclipse of 1999, and in that the author claims that from his analysis, an eclipse has to be as deep as 93%. Only when it crosses 93% does the eclipse become noticeable by just observing the surroundings. But I wasn't convinced for two reasons. One was because of what I observed on the 21st, and the other one was because I observed the eclipse in December, where I was actually under the path of annularity in northern Kerala. So over there, the maximum obscuration would have been something like 93%. Nevertheless, almost some 20 to 30 minutes before annularity, I could see, I could see the quality of the light had changed. You'd been getting some, it was that sunset kind of light, not the regular 9 o'clock light. It's the sunset kind of light, which I started noticing just almost 30 minutes before annularity, and if I remember, even some 45 to 50 minutes before annularity, I could see that the light had started reducing. So going by what I'd seen there, I'd known what to expect in terms of eclipse light. So I felt like the light had changed. Although, to make matters complicated, it was a little bit cloudy. It was kind of cloudy in Bangalore, but then, just to be sure, I made my assessment at a time when the sun was peeking out of the clouds, when the sun had come out of the clouds. So
There was another thing that I wanted to mention apropos to what you've said. Well, not exactly. I was so busy with my instruments. The eclipse was really short. This annularity was really short. So actually, I missed seeing the eclipse. Now, there was another reason. I'm going to show you the ambient light reduction video in a while now, but it never got as dark as a total solar eclipse. I was able to see the camera controls, and in a total solar eclipse, I have experienced that you go like I have experienced the 4-minute totality at the Turkish. I was in Turkey in 2006, and there, for the first minute, I was not able to see the camera controls. If there is a computer screen in front of you, you are absolutely blinded. So it becomes like you're not able to write. But here in this eclipse, everything was visible. Even 1% of the light coming from the sun, and even from the limb of the sun, is very bright, very bright. Although in the ambient light video that I'm going to show you, it appears that it got very dark for a short while, but it was not. I also miss, I was so involved in so many experiments going on correctly that I was not able to look up. But did I want to look up? I did try for a second to the thought was very dangerous to me. Like it was not gone dark like a total solar eclipse. In a total solar eclipse, you want to look up. In this, I was frightened that if I look up, this brightness is so much that I'm going to lose my eyes. And on the Facebook, somebody had asked me that you have presented a photograph of the corona. Were you able to see the corona? No, I was afraid to look up. Even the light which was coming from that 1% from the limb of the sun, it was extremely bright. And I tried to look up, but my mind told me, no, it's dangerous. So that was a thing. But I do miss looking out for the planets. I should have taken time out and checked whether Venus was visible or not. Well, I got reports from some other people at Suratgarh and at Kurukshetra that Venus was clearly visible in that dim light.
Yeah, that would have been really good. I think this was a very unique eclipse.
Okay, so let me get on with my presentation now. On the day of the eclipse, while we were able to broadcast on timeanddate.com very successfully, the YouTube broadcast did not go as well, and it started about 20 minutes late. Over here, these are the instruments which were broadcasting live. This is the Atlas mount, and there is an 8-inch telescope with a full frame camera which was providing the feed to timeanddate.com. And over here, there's a small finder scope with a camera which was providing a wired feed to a television inside the resort. And finally, there is a refractor over here which with the eyepiece and a cell phone which was providing feed to youtube.com. The youtube.com feed started late. There were a lot of people waiting and they got exasperated, and I got some bad words also in the process. But the but the YouTube feed started about 20 minutes later, and there was a switch in the URL. But the time and date feed went off very well, and everything is the 5 hour live programming is recorded on their website, and you can go and see. Let me copy these links in the chat window if anybody wants to go and see these programs. So if you want to watch these live programming, not so live now, half a lunation later, you can copy these links and check them out. So the first one is from Time and Date. Second one is also from Time and Date, but on YouTube. And the third one is the YouTube video that I was broadcasting directly.
But I think it's the link to your channel, right? It's not the link to the video.
That's right. It's not directly, but the video will be present in the first one or two.
Okay, okay.
Okay. Well, okay, 1 hour and 10 minutes now. These eclipses have been a family affair for me. I started going to eclipses with my wife 1 year after we got married. So on the left over here, you can see me and my wife in the eclipse of 1995 at Barkakana near Ranchi. And this over here, after we had children, this is Nakul, who was 2 years old, and this is Arjun, who was 5 years old during the eclipse of 2006 at Turkey. So it's a really interesting thing that we do. We like to go to the eclipses together. So it's like a vacation which we never plan, but the eclipses plan for us. For example, Barkakana, we went there, we would never go there again. These are places which you will never plan, only because the eclipse was happening. The 2006 eclipse, we went to a place called Sideh in Turkey. We would have never imagined that we're going to Turkey. You know, going to Turkey in India was nobody even considered it. But recently, people have been from India have been going to Egypt and Turkey. But in 2006, nobody even thought of going to Turkey. And Sirsa as a district is in Haryana. I know it's there, but I never planned to go there. But this time, just because of the eclipse, I went there. So eclipse travel with family is like you would go and see places which you never even consider to go in any case. So I would like to show over here the small portion, abridged version of the live programming on timeanddate.com. So they had the timeanddate.com, they had programming from about 6 places in the world, starting from Saudi Arabia, where it was partial, then a location in Pakistan, and their main location was.
Here we are again. About every 6 months, the sun and the moon line up in the sky and produce somewhere in the world a solar eclipse.
Wanted to remind everyone that we're going to be showing some spectacular.
Ooh, so sorry.
Line up in the sky and produce somewhere in the world a solar eclipse.
Is the video
everyone that
audio visible? Sorry, audio audible?
Annular eclipse images coming up here from our main feed in India, from Sirsa, India.
There's a lot to come and a lot to happen, especially at
Yes, it's audible.
in
Thank you.
India.
Yeah. So we have a schedule for Sirsa. Yeah, there it comes up. And this is our main feed. We've got some really great friends in Sirsa. Neelam and Ajay, and they've traveled to provide us these beautiful images because we couldn't do it ourselves with the mobile observatory.
That's right. So this is a wonderful husband and wife eclipse chasing team. Ajay and Neelam Talwar. They are based in New Delhi. They've been chasing eclipses together since 1995. In fact, Anna, they're not just a husband and wife eclipse chasing team. They now also take their two young children with them. Since 2005, they have been traveling the world to observe and photograph and film eclipses as a family. Today, this is very much a local eclipse for them. So, of course, with all the travel restrictions that we have at the moment, of course, we had to find local partners. So they were very fortunate. They jumped into a car on Friday from New Delhi, and they drove about 3 hours northwest of New Delhi. It's about 240 kilometers to the city of Sirsa in northern India. And the partial eclipse began around about 45 minutes ago in Sirsa. We're looking at the live pictures right there in the top right part of the screen. Now, of course, the big highlight will be annularity. This is where the moon will move more and more across the sun.
So this is a live feed that we are providing from our instruments. They had tied up with many people across the world, starting from Saudi Arabia, Pakistan, and we were here in India. And then in Taiwan for the last part of the eclipse. So we had some clouds coming in.
See a full ring of fire from India. I still see some clouds going by there. I'm hoping that they're just passing clouds in about 20 minutes time.
That's right. So again, yes, 6:26 is the annularity in Sirsa.
Looking at some images there from Sirsa.
10 minutes before the annularity.
Oh, there are a few clouds there that are really annoying me, Graham.
How about that? We've had pretty much clear skies from our feeds so far, and now here we are, 10 minutes away from annularity, and those clouds are causing a bit of concern. But Anna, I'm sure this is going to go fine for us. I'm sure we're going to get a great view of annularity here.
Yeah, I'm hoping for that. And what do we look out for during annularity?
Well, the great thing with annularity is that crescent sun, the two tips of the crescent sun, they wrap their way further and further around the dark circle of the moon. It becomes quite mesmerizing as the ring gets closer and closer to being formed until finally the sun forms a complete ring around the dark moon. We're going to see this happening over the next 9 minutes here from Sirsa. One other thing to look out for as annularity begins is Bailey's beads.
So this was the highlight of the live programming on time and date. We were able to stream the Bailey's beads really clearly, and we got a lot of comments from around the world appreciating the feed. This particular instrument that was being used was at 2000 mm focal length with a full frame camera, which is capturing the entire sun. Although the tracking had to be really precise because the frame of the camera was almost equal to the size of the sun. So the tracking had to be really precise, and polar alignment was done over 2 nights. Even then, it is not possible to track the sun. You have to
Well,
keep a
we're
visual.
back and wow, that was pretty awesome. Wasn't it, Graham?
That was great. We got lucky with the clouds, and we had beautiful angularity from Sirsa. Absolutely.
Okay, I've come to almost the end of my presentation, and these are some pictures from location. We had a group, like the location was good. Sirsa, what? It's very overwhelming what to have accomplished this family expedition along with other people who were there. Feels very nice, feels very accomplished. This is never we're not going to ever be able to carry so much equipment to the path of an eclipse anywhere in the near future. Okay, so I am here to answer the questions. Sriram has said the 1995 eclipse was also quite short, but presented some bright coronal streamers. Yes, Sriram. At in Rajasthan, the 1995 eclipse the duration was about 40 seconds, and where we were at Barkakana, the duration of totality was about 70 seconds. Diamond Harbour also became near Calcutta, also became very famous. The duration was more over there, I think about 75 or 80 seconds. Kirti Kiran has asked, are these all your equipment? Uh, the 14-inch is mine, the 12-inch is mine, the Atlas mount. There was a telescope over there, 8-inch telescope, which belongs to Adi, and there was a refractor in front which belonged to Nilesh. But yes, all the equipment are mine, gathered over the years. Thanks, Kirti. Okay, at the end, I would like to play the movie again, and I will wait for your questions. This is actually the end of my presentation, but I'd like to play the movie again. So here you can see corona, all the subsequent images. In this ambient light dimming video, it appears that it had become extremely dark. But as Amit and we were discussing just after the eclipse, it never really became as dark as a total solar eclipse. We were able to see the controls, we were able to see what was written on the paper. Kirti has mentioned that corona was visible also after C3. Yeah, that's right, Kirti. But it was more prominent before C2. Sriram has written one last question. Is there anything in solar eclipses that is still to be understood? Anything that is still left to be checked out through observation? Corona is only visible when there is a solar eclipse. Although if you have a telescope in space, you can put a occulting disk in front and deliberately cause an eclipse over there. But still, you cannot have a total solar eclipse because the occulting disk has to be very big, kind of two solar radii. So the inner corona can only be observed during a natural solar eclipse. So there is a big question which is still undecided and not verified. How does corona go? The temperature of the corona is very high. So the reason is not yet understood. So eclipses are the only way that the innermost corona can be seen and observed. And that too only total solar eclipses are the only way at the moment when corona can be observed. So this question, which has no answer till now, they are working towards answering this question during solar eclipses and during particularly total solar eclipses. Apart from that, it's a beautiful phenomena and always proves to be different. You go to a different solar eclipse, the corona, the shape of the corona is different and circumstances are different. So humanly, artistically, it's always different, always fascinating. Sudhansha said, felt as if we were there with you. Amazing preparation and awesome results. So thank you, Sudhansh. Kirti said, really, really amazing, which is the next eclipse that you're planning to watch. Well, now that the corona adrenaline has been pumped into our bodies on June 21st, I'm trying to go to Chile or Argentina, rather Argentina, for the December eclipse, but I don't know whether it will be possible. Whether so it's still if, but I'm trying. Srirama said, I think that your observation that there was no annularity from Sirsa brings up the importance of observation during eclipses, especially of contact timing and determination of percentage of the sun covered. Yes, very much important. And some of the people especially go to the edge of the path even during a total solar eclipse. So they go and stand on the northern edge and on the southern edge at various places to check the whether the moon is occulting the entire sun or not. So they miss the corona in the central part and they go for Bailey's beat at the corner, the edges of the path. Amit Bhattacharya has said great images. The corona images were fantastic. On hindsight, I should have used a camera without filter. Yes, Amit. Quietly, Manish Sharma did it, and his photographs were fantastic. Kirti Kiran has said, it is so unfortunate that the astrologers get so much attention and hundreds of thousands of views, but the efforts of amateur astronomers goes almost unnoticed. Yes, sometimes I think, Kirti, that I should become a astrologer and I would earn a lot of money that way. So, yeah. So, Vishwa, that's the end of my presentation. And if there are any more questions, I'll be happy to answer. Nagendra says, I was mesmerized as an engineer. I found your preparation and your technical scientific explanations were very good. Well, thank you very much, Nagendra.
Hey Ajay, thank you very much. I mean, it was literally like the entire content, the entire videos. It was literally like we were actually there and observing the eclipse. So I even caught some of the live stream that you were doing on time and date. And yeah, there were a lot of clouds here, and even I tried to capture some of the images, but I really did not have the kind of preparation that you had undertaken. Yeah, and I simply ended up watching your live stream on time and date. It was really awesome, and again, once again, thanks for having this session and explaining all the intricate details and everything that you did during the time of eclipse. Thank you very much.
Thank you, Vishwa. Thanks a lot for organizing. Thank you, Kirti.
Yeah,
And thank you all the
thanks. The whole
participants
team.
for.
Yeah, actually, apart you as well as the other people who were there, I think you guys did a really fantastic job. Thanks a lot for all the photos and all the effort that you did.
Thank you, Kirti.